Hi everyone, this is Erwin. We are going to do a project for our fluid class. My friend is helping with me to explain the Bernoulli principle. Today I have one experiment to explain the Bernoulli principle, and my friend is going to do another experiment to use Bernoulli equation to solve the equation. So for the first part, I have this setup that we needed to do the experiment. For this experiment, we need straw, few cups, one balloon. What we're gonna do is we're gonna put some hole at the bottom of the both cups. We are going to put a straw in them. The only difference is gonna be is the one cup has no holes on the side and the other cup is gonna have some holes on the side. So let me explain the first part. What is Bernoulli? Yeah, so the Bernoulli principle says high pressure, low velocity, and high velocity, low pressure. So that's what I'm going to explain you today. So this is our setup for today's experiment. As I explained, we need some hole. So for saving some time, I've already prepared everything that we need for today. These are two cups, and this is the setup we're gonna use today. This is the cup with the no holes and straw at the bottom, and this is the one with the holes on the side and with the straw on the bottom. So let's start the experiment. What we're gonna do is put the balloon on the top and blow some air from the bottom, and let's see what's gonna happen. So let's try this. So as you can see is whenever I blow the air from the bottom, the balloon gets stuck with the cup, and if I tilt the cup, the balloon goes with it. The process that's happening inside the cup is whenever we blow the air, the velocity inside the cup increases, resulting in decrease in pressure inside the cup. So the balloon gets attracted toward the cup, and whenever we tilt the cup, these two things get attached with each other and it just moves with the cup. And the first second part, we were gonna use the cup with the holes on it. And here, for the second part, I have a cup with the holes in it. So what we're gonna do is put the balloon on the top again and blow some air from the bottom and see what's gonna happen. So let's try it. Let's do it again. As you can see, the balloon get flipped over. It's not stuck with the bottom. The reason behind it is it has got too many holes around it. So whenever I blow the air, the pressure inside does not decrease it. The air just moves away, and the little bit air that remains inside it is enough to blow the balloon outside. So the Bernoulli principle clearly says, clearly justified by this experiment. So that's all I'm gonna do today. In my next video, my friend is gonna explain how we're gonna use the Bernoulli equation and solve a problem related with it. Thank you.
Hello everyone. In the last video we explained the principle of Bernoulli equations, and in this experiment we're trying to find out the velocity by using the Bernoulli equations. So we have in this tank, this can is filled with water, and the height we already measured is like 15 centimeter, and we have a hole from the side. Right now we're trying to open the hole and to find the velocity. Let's try to open the hole. So we'll find the... Hello everyone. Today we're trying to find out the velocity by using the Bernoulli equation, and here we have that's the tank, and we have the height 15 centimeter, and we're trying to find the velocity over here. So by using the Bernoulli equations, we have to determine like 2 points over here to find the velocity. The first point, let's say the first point, it's right here at the atmosphere pressure, open atmosphere. This is 1, and here point 2 over here. We take it as a reference. So Bernoulli's equations, it says that pressure at 1 plus rho g h height at 1 plus 1/2 1/2 rho velocity at 1 square equal pressure at 2 plus rho g, the height at 2, plus 1/2 rho velocity at 2. So right now we have this at this point we have the open atmosphere pressure. So this pressure at point 1 equal to the pressure at 2. So they both cancel out. And also we have the height at 1, we have which is 15 centimeter. So like we need this information over here. And the next one, we have the velocity at point 1, which is 0. So we cancel the whole thing. This is whole thing be 0. And the height at 2 also it's 0. So we cancel this. Also this is equal to 0. So we left over with this because we want trying to find out the velocity at point 2. So that's what we left over with. So we have rho g h1 equal 1/2 rho velocity at point 2 square. So both we cancel both rho over here, and we left over with, let's put this in the other side, 2g h1 at point 1 equal velocity 2 square, and velocity 2 square, velocity 2 equal square root of 2g h1. And we say we have, let's plug the numbers, 2 times 9.8 meter per second square times height at 1 h or u, the same thing, which is 15, which is 0.15 meter. We convert it to meter. That's equal to the velocity at 2 equal 1.714 meter per second. That's how we determine the velocity. Thank you.